Okay, welcome to September edition of Green Infrastructure, Climate, and Cities. My name is Franco Montalto. I'm a professor here at Drexel. It's a little quiet period at Drexel because we're in our break right before the fall quarter, but thanks to those of you who are attending online. For those of you who happen to be joining us for the first time, this is a series that's been going on since 2014. We've got monthly speakers on a variety of topics associated with green infrastructure, climate, and cities from a physical and a social perspective. And all of our previous talks are archived and you can look them up. This is webcast. Actually next month is the end of the 2018 season, and we'll be making an announcement, likely going to be continuing for the 2019 season, but we'll be making that announcement next month. So today's topic is focusing on green infrastructure in New York City, green stormwater infrastructure in New York City, and I'll talk about that in a moment. I'm actually listed as the presenter. However, the work that I'm going to present today is the doctoral research of Dr. Stephanie Miller. She got her PhD here at Drexel in my group and graduated last year. And she's now got a job working out in Colorado and was not able to make it. So I'm presenting 2 chapters of her dissertation work today. And I'll shift to that now. So I should mention that the format for this presentation is two PowerPoints. And those of you who are joining online and who also attended the Nashville, the 2018 Low Impact Development Conference in Nashville, Tennessee last month have seen some of these because these have been adapted from that presentation. So they're 2 separate conference presentations, and I'll give them back to back. The first presentation is focusing on stakeholder perceptions of green infrastructure in New York City, and this was a several-year effort that Stephanie undertook to try to understand how people in New York City see green infrastructure and the benefits that it can provide. And so this first presentation is the results of this stakeholder engagement activity. And then the second presentation, what Stephanie did, which is very interesting, is took the results of this survey and then built it into an agent-based model and did some forecasting 20 years out at, based on both the physical, the economic, as well as the social sort of impact of green infrastructure in New York City. Where will that get us? And so the first presentation is sort of the results of this interaction with these stakeholders, and then the second presentation is the focus, is focusing on the agent-based modeling. So just by way of orientation, since this is green infrastructure, climate, and cities, and people in this session have talked about all different types of green infrastructure, and of course, we do think of green infrastructure as encompassing all of the natural capital within a city. But the focus of this talk is specifically on green stormwater infrastructure. So this is a subset of all green infrastructure that is being cited and designed specifically to manage stormwater. And so a variety of different types of green spaces. These are mainly images from New York City, although one in Philadelphia, talking about different ways that stormwater is being managed using green spaces in a decentralized way on public and private property. So you might say, especially if you come at this from a government perspective, why do stakeholder perceptions matter, right? We're building these things, they're managing water. And I think there's a variety of reasons why perceptions matter, or at least why we undertook this study. I should mention up front, this study, although we're focusing on green infrastructure in New York City, was not funded by the City of New York. It was funded by both NOAA, the same source of funding for this seminar series, and the National Science Foundation. But to a great extent, truth is perception, right? Or perception is truth. So how people see green infrastructure matters quite a bit, especially when they go back and talk to their elected representatives, or they report back to their supervisor if they're government employees. So the perception, what people see when they see these green spaces, very much influences sort of the whole process that is involved in building green infrastructure in cities. So the next thing is expectations, right? So stakeholders expect certain services from these investments. They expect to get something in return. And it's very interesting, having worked in various communities, is that what people expect from green infrastructure and what the expectations are of those who are investing in green infrastructure are not necessarily aligned. So, there could be an investment in green infrastructure made for a certain reason, and then the expectation from others who see this green infrastructure arriving in their community could be quite different. So, this distinction is important. And then the third is sort of informing this alignment activity. So how can we inform policy and design with local preferences in mind? So if we understand that people would like to see this flavor of green infrastructure more so than that flavor, and in fact, if you make it this flavor, they'll be more supportive of the whole thing. That helps you to build support. So that's the framing for why we undertook this study to begin with. So we are focusing on ecosystem services, and we probably all know this in the context of this seminar series, but ecosystem services refer to the benefits that people get from an ecosystem. In an urban environment, not all of the sort of full suite of ecosystem services that are discussed globally are relevant. There are certain ones that are more relevant. In fact, Stephanie actually went through all of the literature on this and came up with a short list of about 22 services that we thought were appropriate to consider in the context of green stormwater management. In other words, services that could potentially be provided by green stormwater infrastructure in a city. And they fall into the typical categories of provisioning services, supporting services, cultural services, and regulating services. And one thing that I wanted to sort of also mention up front is that there is no standard way for trying to put a value on an ecosystem service. There's a lot of different approaches that are out there. We have these traditional economic valuation methods, willingness to pay, cost-benefit analyses that sort of zoom in a certain way on some services. And then increasingly you're seeing these integrated analyses like landscape preference surveys, collaborative mapping. These are more interactive environments where you, through interactions with stakeholders, you can get a broader perspective on this. But there's certainly no one right way for doing this type of a study. So no consensus approach. I don't know why that came out like that. Sorry, I wasn't supposed to do that. That's what I was looking for next. In any case, you also can't easily generalize from place to place because the perspectives of different stakeholders differ from one another. And so these valuations need to be performed locally, and they're dependent on local conditions. So again, we're focusing on New York City. And this is just a preliminary attempt to focus on that second type, this integrated socio-cultural valuation. And we're focusing on ecosystem services in New York City's stormwater green infrastructure. And so our goals were three. We wanted to determine the services that different stakeholders, and I'll talk about in a moment which stakeholders we targeted, value from different GI types. And then we wanted to contrast these different perceptions. And then we also wanted to compare perceptions with the best we could do in terms of objective facts. In other words, we looked at the literature and said, well, has it been shown that this type of green infrastructure can actually provide this type of service? Is it technically possible? And then if it is, do people see it? Do people appreciate that possibility, or vice versa? And then, again, we wanted to use this to try to tailor green infrastructure investments so that we're managing stormwater, but we're also helping to increase public acceptance, and that's more in the second presentation. So our methods included a structured survey. I should mention, before we created this structured survey, we did months of semi-structured interviews with experts in New York to try to design the survey itself. We did, in the beginning of the survey, we showed pictures of different types of green infrastructure, and then we asked respondents to indicate if they thought of each of these different services was provided by checking a box by the different types of green infrastructure. So we focused on 6 types of green infrastructure. We sort of bundled together bioswales, rain gardens, and green streets. In New York City, green streets means these sort of vegetated green spaces in intersections, irregularly shaped green spaces that are built. Originally, the Green Streets program in New York City was an urban beautification program to take unnecessarily paved spaces and make them beautiful. Since the city started using green infrastructure for managing stormwater, a lot of those have been depressed and water's been sent in them. So that's one category. Then green roofs, street trees, community gardens that have a rainwater harvesting component, general parks and natural areas, and then the last are permeable playgrounds. So what we did in this survey was we listed, so they provide desirable habitat for birds and animals. So we didn't use the word ecosystem services. We sort of boiled it down to something that people can relate to and said, do you think any of these things provide that service? And we went through that for all the services that I mentioned previously. We also asked general questions, demographic information about the survey respondents, and and tried to also gain some information about their familiarity with green infrastructure. So for statistical reasons, our New York City has a certain population. We were focusing on the Bronx. We had a target study size of 384, and that was basically to get 95% confidence level and 5% confidence interval for the whole city. And what we did was tried to get to that target by looking at 4 different stakeholder groups. The first group, and I'll mention how these groups relate to one another in a moment, but the first group were practitioners of green infrastructure, and they were recruited through direct email communication. So these are people who we knew of who either are involved in designing, planning, building, operating, maintaining, constructing green infrastructure. The second group of participants were recruited through a snowball approach, and these were folks who are related to, who know someone who's worked in green infrastructure. And the way we recruited these people were, our lab group hires citizens, and we have a citizen scientist program, and we engage those folks in helping us to maintain our monitoring setups in green infrastructure in New York. And so what we did was gave the survey to a core group of these citizen scientists who've worked with us over the past couple of years, and we asked them to share the survey with their friends and relatives. And so it was a snowball approach, and so these are people who know someone who works in green infrastructure. The third grouping were individuals who we found through a drop-off pickup method. So we went into a park in the Bronx, and we simply distributed the survey to folks who were in the park. And so now you're talking about a specific type of green infrastructure, park users, but these are people who are out there in the environment and at least have decided to go to a park. And then the fourth group were actually purchased through SurveyMonkey audience. So SurveyMonkey will, you tell them the characteristics that you want, and we wanted these to be representative New Yorkers. So we purchased a certain number of respondents. So you could think of groups 1 through 4 as decreasing in terms of the level of exposure and or knowledge that people have of green infrastructure, from the folks who are actually involved in building it, designing it, to people working in it, to people who just sort of visiting a park, and then finally to just general New Yorkers. In addition to interviewing people, I mentioned that we were interested in comparing perceptions to quote-unquote reality. And so what we did was an extensive lit review, cross-referencing these different services with the different types of green infrastructure, and indicating whether the literature generally says that that type of green infrastructure can provide, so the idea of a community garden providing food, the literature suggests yes, a community garden can provide food. Bioswales providing biodiversity, the literature says yes. Bioswales providing water, the literature says no, right? So, or if it was a mixed bag, in other words, if whether or not that type of green infrastructure could provide that service depended on how it was designed, how it was placed, we kind of left it out. But what we did here was then compared, so you see the codes there, BGS, and the 1, 2, 3, 4, 5, 6, and then there's other ones. we then compared the perceptions in these categories with what the literature says. And I should mention, this came from a review of 426 Web of Science papers, and with fairly high impact factor. So these were good scientific studies that we reviewed. So there's a little bit on the response rate. We got a pretty good response. So the practitioners, we got 20, 57% response rate. The citizen scientists, we got 20. There's no rate because that was the snowball sampling. The in-person recruitment in parks, we got a 22% response rate, and then SurveyMonkey, we got 19%. So we got a pretty good distribution of folks. So let's talk a little bit about some of the results. And there are different ways that I'm going to present this data, sometimes in tables, sometimes in graphical format, so I'll try to describe here. So these two initial questions are, have you ever seen a bioswale in your neighborhood or around the city before? And then down below, have you ever seen a green roof in your neighborhood or around the city? And so one thing that was interesting is that people have generally more experience with bioswales. So the numbers for each of the groups, with the exception of group 1, the practitioners knew about both of these. But groups 2, 3, and 4, the numbers in the upper table are greater than in the lower table. So generally, people were more familiar with bioswales, this right-of-way form of green infrastructure, than green roofs, possibly because the green roofs are harder to see, harder to access. So there was, that was one thing. The next thing was that in order of going from group 1 to 4, so from the highest level of familiarity or exposure to green infrastructure to the least, we had a reduction. So certainly, as you go from 100 to 41, 100 to 54, the less exposure you have, the less likely you seem to be to have observed or seen one of these features in your neighborhood. So, this was kind of interesting. People who work with green infrastructure are generally more familiar than, or generally have seen these features in their neighborhood than someone who knows someone, a park user, or an average New Yorker. This is very busy, and let me explain it before I talk about what it means. So across the top, you've got these, there's group 1, group 2, group 3, group 4, and then in each group you've got, bioswales, community gardens, green roofs, the same 6 types of green infrastructure. And then down on the column here are the services that we interviewed people with. And then these squares are the percentage of the people in that group who think that type of green infrastructure can provide that type of service, and they vary from 0 to 100, right? So it's sort of a visual way of presenting the results of the survey. And so when you have lots of blue, you're up near 100, so there's sort of a lot of consensus here that parks and natural areas can provide all of these services. For example, among the practitioners, you can see there's also a lot of consensus here that the practitioners see that all these types of green infrastructure potentially can provide water regulation. But then you've got other examples of where very little, you've got lots of red down near 0. So, there are situations where, for example, trees and potable water supply or potable water, virtually nobody thinks that a tree pit is going to provide potable water. And then you've got the yellow that's sort of in the middle. So there's a mixed bag. People don't necessarily agree with one another. So one of the things that comes out of this is there's the least amount of yellow in this first quadrant here, which we interpret as meaning practitioners agree with one another the most about the value of various ecosystem service green infrastructure combinations. In other words, they tend to generally all agree, yes, this can provide it, or no, this cannot provide it. There's not a situation where the practitioners are sort of, half of them are saying it can and half of them it can't. Whereas you see the amount of yellow that you see going from left to right starts to increase. So there's more divergent opinions with less exposure. That was one interesting thing. Another interesting thing, if you look across all the groups, and I put these little triangles here to help you see parks and natural areas, community gardens, and bioswales. if you look at the amount of red in those columns, there's the least amount of red. So in other words, of the 6 types of green infrastructure that we talk to people about, generally people think that these types can provide the most services. And that was very interesting to us. Perhaps not surprising that people, kind of understand parks and community gardens are, especially in the Bronx, are all over the place, and bioswales are very present. But that was interesting. Another way of looking at this is this same data. We now PVC is so I should mention, we're calling this color a public value coefficient. So it's a percentage, but it's a public value coefficient. So when I talk about PVC values, that's what I mean. So when we take, when we average all ecosystem services for, in other words, go down the column, all of the services for the different groups, we see a few interesting things emerge here. So one is the parks and natural areas are ranked number 1 if you look at all groups, followed by community gardens, followed by bioswales, then street trees, then green roofs, and then finally permeable playgrounds. So permeable playgrounds, perhaps because they're most of what that is happening underground, are sort of the least appreciated, and parks and natural areas seem to be the most appreciated. Practitioners value all ecosystem services and all GI types more highly than other response groups. So this is all GI types. This is group 1. That's 63 going down to, this is the only one that's kind of out of order, the 44. But generally, the ecosystem service value of all types of green infrastructure is more appreciated by those who are involved in designing and building them. Sorry that when I moved this to a different computer, these things shifted. But the other thing that's interesting, now what we've got are the groups, and instead of across the top, the different types of green infrastructure, we've got the different types of services. And so if you look at the bottom of the column, these are provisioning, supporting, cultural, and regulating. The highest number is cultural services. So all 4 stakeholder groups tend to value cultural services of green infrastructure more than of the other services, including regulating services, which is the reason that this type of green infrastructure is being built. It's being built to manage stormwater. So people are appreciating these other cultural impacts or cultural values of these types of systems. So now I want to talk about the comparison of the perceptions to what we found from the lit review. And I'm going to present it in a format like this. Again, I have to sort of take you through what this means. So this chart, for example, is only the yes green infrastructure ecosystem combinations. In other words, only the combinations where the literature suggests, bless you, that type of green infrastructure can provide that service, right? So it's only the yes combinations. The no one we'll talk about next. And then what we show on these is from 0 to 100 on the x-axis. On the horizontal axis, that's the group 1, those are the practitioners. And then on the vertical axis, in this case, is group 2. So I'm going to show you 3 of these charts comparing each of the other stakeholder groups to the practitioner group. And then so in this region up here, the literature suggests yes, and the perceptions of both groups, the practitioner group and this group 2, are up in the upper region. So there's agreement with the literature. What we did is then, in this region where either one of the 2 groups, less than 25% of them, believed that that type of green infrastructure could provide the service, we called that out with a code. So there's a letter, the G is green, green roofs, and the 13 is a code that refers to one of the services. So I'll now talk about these. We call these the outliers. These are places where people disagree with the literature, and it's kind of interesting to look at where they are. So now we're comparing group 2 to group 1, group 3 to group 1, and group 4 to group 1, and you've got all these different outliers here. So I'll just point out a few of them. Participants agreed with the literature most regarding street trees and parks and natural areas. In other words, there were a few outliers that start, if you look at all the outliers, very few of them start with an S for street trees or an N for natural areas. So it's consistent with what we heard before. People generally appreciate parks and natural areas, and literature is telling that parks and natural areas and street trees can provide these services, and so people kind of understand that. Stakeholders undervalued the benefits from permeable playgrounds the most. So if you look, across all these things, there are P's. Here's a P there. Here's a P there. A P here. Lots of P's. That may be the way we market permeable playgrounds. We just kind of build the playground, and people don't necessarily know that the material is porous and allowing the water to go below the surface. But there's certainly the literature suggests that you can get a lot out of permeable playgrounds, and the people who we talked to didn't seem to necessarily realize that. And if you look at the numbers after the codes, the numbers 11 through 22 are these regulating services, things like stormwater management, energy management, et cetera. And what you see is there's a lot of the outliers are with between 11 and 22. So we interpret that as that stakeholders were undervaluing regulating services the most. So this may be a marketing problem. Like, in other words, we're building green infrastructure. A lot of the money for green infrastructure is for water regulation, and yet people aren't seeing necessarily the water regulation. They're seeing other things. So a couple of other things here. All groups believe that bioswales do not provide valuable recreation, and that could be just because of the way bioswales are built in New York City. There's a very standard design. It's surrounded by a fence. It's not an opportunity for gardening necessarily. However, the literature suggests that you've got these pocket gardens in people's neighborhood. You could create a recreational benefit from bioswales, but it seems that people, as a result of that, don't necessarily see a recreation value to bioswales. But that might be a missed opportunity. That might be something that through a design modification you might be able to build in. So now let's talk about the no combinations. Those were the yes combinations. So this is places where the literature says no. That green infrastructure cannot provide that service. And again, we've got the region over there where we're not calling them out, where basically the two stakeholder groups are agreeing with the literature, and then we're calling out, in this case, the outliers are in the upper right, because the people do think that type of green infrastructure can provide that service, but the literature says no. So here's now the three groups there, and there's a few things that we can say. First of all, it's less likely that stakeholders are overvaluing green infrastructure than undervaluing it. In other words, there's a lot fewer outliers here. So people, are undervaluing, or not. They're not overvaluing. All groups seem to be overestimating the nutrient cycling capabilities of green roofs and community gardens. So the literature's saying no. There's information out there that says that green roofs could discharge nutrients, for example, but all these groups tend to think that there is some kind of nutrient cycling value to green roofs and community gardens. And that seems to be not substantiated by the literature. And then this group 4, which remember is the just sort of general New Yorkers, there was an interesting B2. They are associating bioswales with the water supply. So there's a perception that among at least the general New Yorkers that we interviewed that not shared by group 1, so it's over to the left, but it's high on the vertical axis there, that somehow bioswales are improving the quality of New York City's water supply. And of course, in New York City, we're not drinking the groundwater, so that's not the case. But that's kind of an interesting perception that general New Yorkers have, that this is somehow impacting the water supply. So the conclusions from this part of the research is that maybe green infrastructure messaging should focus less on stormwater management, one of these regulating services, and more around the services that residents seem to value when they see green infrastructure. And at least this study is suggesting that cultural services, like the possibility of gardening, getting together, are more highly valued by residents. Aesthetics, for example, more highly valued than these regulating services, regardless of GI type. And the other sort of tentative conclusion here is that there are types of green infrastructure that are currently not emphasized, in particular community gardens, right? So community gardens are not, the city is not spending money to systematically upgrade community gardens so that they are receiving stormwater. There are about 100 community gardens in New York City that do harvest rainwater from adjacent rooftops, but that was done sort of in an ad hoc grassroots way over time as the city was responding to various droughts, and there were irrigation restrictions imposed on community gardeners, and so people had to take it into their own hands and they built cisterns. But the $1 billion green infrastructure plan in New York City is not deliberately taking advantage of these community gardens and sort of rolling them into the program. And although there is some new work now in parks and natural areas, so the Department of Environmental Protection is collaborating with the New York City Parks Department and exploring different ways of directing stormwater from streets into parks. This is sort of a new practice. It's being done in Philadelphia as well. But that seems like a potential win-win opportunity because people like parks, and by enhancing parks through the investment that the city has to manage stormwater, there's a good chance that we could align goals. And bioswales, of course, although the question with bioswales is, can we build in some of these cultural services so that these aren't just static systems that are plopped down in a neighborhood, but rather are features that people can interact with in ways that that they would like to. So that's the first part of the presentation, focusing on the survey. And I'm happy to take questions on this part if there are any, and then I can go on to how we then took these perceptions and built them into an agent model and looked at a forecasting over the next several decades to see where green infrastructure might get us. So if there's any questions on this, I can take those now. Like that.
I have a question.
Yeah.
So do you think if green infrastructure not only working on the stormwater management and involve more about like community benefits, is that going to increase the cost for green infrastructure?
Well, so that's an interesting question. So the question is, if you were to design green infrastructure that provides more community benefits, would you increase the cost and then make it less likely to you be able to do more? I think in a very basic sense, it might. It's possible. But on the other hand, the issue that is happening, I think in New York, is that the number of sites where we can build green infrastructure are rapidly getting exhausted, at least in the public right-of-way, right? There's only so many parks, there's only so many schoolyards, there's only so many sidewalks. And so what I see as necessary is the city has to start partnering with other types of property owners in order to be able to access their properties to build green infrastructure. So if you were going to have a rain garden in your backyard, and really what you want to be able to do in your backyard is have a place for your kids to play, and you don't have a place for your kids to play, but you could take this grant from the city and turn your backyard into a playground, but actually it's managing stormwater. That type of a partnership now allows the city to manage stormwater in your backyard. So there might be incrementally additional costs for some of these features, but on the other hand, that may be what's necessary to increase access. And then who knows, maybe there's interesting cost-sharing partnerships where if, back to the playground example, if you were saying, well, hey, if you give me, I was going to spend some money in my backyard anyway, you give me 75% of the money, I'll put in the rest because I want it to be a beautiful place for me to spend with my. So there, that would be an arrangement that would emerge from this. So that might actually contribute to reducing the cost. I also think that there are things that can happen that are not necessarily more costly. So you can, if you change the vegetation that you're putting in a green infrastructure site to something that produces berries, for example, I don't know, making something up that people like to pick. It might be a marginal extra cost, but it creates this more interactive component that you have. So I don't think it's necessarily always true that designing multifunctional green infrastructure is going to be more costly, but but it may be what you need in order to get the level of access that you need to get stormwater management. Okay, so if there's no other questions, I'll move on to the next presentation. So again, this is Stephanie's work. This is the last piece of her dissertation. And here what we were interested in is the long-term economic and social impact of green infrastructure in a section of New York City. And we focused on the Bronx. The Bronx is a place where there's a lot of need for stormwater management and CSO control, combined sewer overflow control. And we started this modeling activity by saying, where will we be in 20 to 30 years? Do we know? We're all investing in green infrastructure now. Do we know in 20 or 30 years where we're going to be? Do we know how much stormwater will be retained? Do we know, in the end, when all is said and done, what's going to be the most common type of green infrastructure that we're going to see around us? What types of relationships will we have in our communities? How will people be interacting with these things? And I think what we believe is that the answer is still unknown, right? There's so much uncertainty built into this thing that we're not exactly sure. And so we saw a value in developing a stochastic model, so a model that allows us to look at a whole bunch of different combinations of things to see where we might be. So we know a few things about what the key drivers may be. So we know that institutional constraints are significant, right? So you can't just expect the Parks Department or the Water Department to be able to do anything anywhere. There are all kinds of issues associated with where a government agency can work and what resources it has available to it, and what sort of legal constraints there are on what it can and can't do. We also know that community response or perception matters, right? And in some cases it can be favorable. The community can be very, very happy that certain things are happening, but if you're in the opposite situation and the community is reacting negatively to something, they can also influence policy and slow down or modify the way that this policy is being implemented. We also know that there's a lot of heterogeneity. There's a lot of things that vary physically, but we made up this word spatio-temporal political, right? There's, people in one place may support one thing at one time, but then at another place and another time, they won't support that, and you can't necessarily predict how those things are going to evolve over time. There's also a lot of innovation happening in green infrastructure right now as we speak. People thinking, even right here in Philadelphia, people thinking about new ways of integrating green infrastructure into environments and new research on how to build the most effective systems. And then we don't know much, but we know that partnering and collaborations are going to be increasingly what we need. And between public and public, different agencies working together, between private and private, and public and private. The problem is that none of the tools that we have available to us for modeling green infrastructure actually allow us to look at those drivers, right? So this is being mean. EPA SWIM, which is sort of an industry standard model that's used by cities to predict, if I have this much green infrastructure in an area that looks like this and I subject it to this rainfall, this is how much runoff I'm going to get, this is how my reduction in CSOs is going to be. But you have to sort of jump to those places, right? You have to construct the model for that future period. But the process of getting there is one that involves all these other dynamics, and we don't know. So we could create an infinite number of models of future situations, but that's time consuming and resource intensive. And so what we wanted to do with this research was to develop an agent-based model. So agent-based models are kind of like SimCity. You develop a game, you put the agents in the game, you decide what the agents can perceive, what they can do, what resources they have available to them, and what is impacted by those actions. And then in agent-based modeling speak, you watch patterns emerge over time, spatially and temporally. So you put the agents into the environment, you design the environment, you design the agents, and then you allow things to interact, and then patterns emerge. So agent-based models are used in lots of different context. People have looked at them in rural environments. There's been research on the Anasazi Indians and the Bali water temples, and lots of economic studies have been done, studies in the stock market. So there's lots of different ways that people use these. Often, so they're multidisciplinary, they're multi-actor, they're multi-domain, so all the things that, say, a swim model or a hydrologic model is not. And one of the main uses of them, since, by adding all this complexity, of course, you've got, you're getting into areas that are not well understood. And so we tend to use agent-based models. We run them thousands of times, and we allow stochastic things to happen lots of different ways, and then different patterns emerge. And we can use them to predict the outcome of different policy decisions, to evaluate the influences on decision-making, to explore socio-ecological linkages, given all the different perturbations of the drivers that we've built, customized into the model. So very few people have used agent models to look at green infrastructure. Our group has used them twice in Philadelphia, working with the Philly Water Department. We've got 2 papers, but very few others have done this. So this is kind of a new application for agent-based models. So what we specifically wanted to do was to use an agent-based model to look at a long-term, in this case 20-year, impact of green infrastructure, focusing on the Bronx. And we wanted to look at the physical, social, and economic consequences of greening the Bronx. And then more specifically, we wanted to compare 2 different policy scenarios. So one was sort of the status quo, where the city builds green infrastructure in priority watersheds, so watersheds that have been identified because they have a large volume of combined sewer overflows, and stormwater needs to be managed first there. The second sort of variation is a different siting strategy. It still works in the priority watersheds of the city, but now it's trying to maximize the co-benefits that the greening can have on people, and that's the interface with the previous study. So I'll talk more about that in a moment. But we built our model in NetLogo. NetLogo is a free open source software. They call it a low threshold, no ceiling. In other words, you can learn how to use it quickly, and there's no limit to what you can do. It's got its own unique programming language. It's a little bit like Java. It's generally described as turtles and patches. You create patches, and you put turtles, and the turtles interact on the patches. Stephanie wanted you to see one screenshot of her code so you can see what it ultimately looks like. So we focused on a section of the Bronx that is majority minority, total population 825,000, average income is relatively low for New York City levels. It includes portions of the watersheds of the Bronx River, the Hutchinson River, the Westchester Creek, and the East River open waters. And so what you see, those columns there are the impervious areas within the combined sewer districts, the total numbers, then the percentage of the watershed that's included in the model, and then the target in terms of greened acres that the city would ideally like to achieve in each of those watersheds. And then the spending. We estimated the spending based on the amount that green infrastructure has been costing to date. So we took per greened acre based on the last few years of data, and also based on projected budgeting that the city has done over the next 20 years. We know more or less how much money they're going to be able to spend. So, so it's constrained economically is what I wanted to say there. So we could think of it as the model contains, obviously I could talk for 5 hours about the model. I'm not going to do that. But the model contains passive agents and active agents. So active agents are, in this case, mainly government agencies, but also nonprofit. You see TPL, the Trust for Public Land, but also private property owners who participate in greening different surfaces at different points in time. And then the passive agents are parcels of land that become green infrastructure or not. So, we've got streets and right-of-way, schools, public housing, other public properties, parklands and playgrounds, and private properties. And then each of these passive spaces, there are different decision pathways. So like if you look at the streets and right-of-way, a specific patch of street could become a bioswale, a tree pit, a permeable pavement, depending on the decisions of the active agents who operate on streets, in this case the DEP and the Department of Transportation. So that's generally the types of agents that we had to develop rules for, and then the rules impact those passive spaces. The model also has these global influences built in. So, excuse me, institutionally, we didn't allow green infrastructure to happen in places where it's illegal or where other factors would never allow it to occur. So how, what, and when GI is installed was realistic based on institutional constraints that we learned from our semi-structured interviews. Then there are monetary constraints, so there's only so much money that's available for each year. The yearly spending is based on the real spending that happened between 2010 and 2016. So we constrained the amount of money that can be invested. We had lots of information. Now, I mean, green infrastructure has been happening now for several years, and so we know there's a certain sort of probability that a site will actually be able to be built once they start investigating the site based on issues of bedrock. In the Bronx, there's a lot of bedrock, soil permeability, utilities. So we had, there is a probability that some of these sites don't actually get built, and we took that into consideration. And then finally, the stormwater priorities. So we focused in combined sewers, and we focused within the combined sewer district in these priority watersheds. And we only allowed investment of green infrastructure on public lots and streets that fall within priority sewer sheds, as well as sort of private properties, but mainly the public properties. So that's the global influences in the model. Then we tracked, so this just shows you the acres greened, so the percentage and then the target and then the spending. So for example, in the Bronx River watershed, the target based on the percentage of this that's in the model is 233 acres, and we know that the maximum spending is $119 million for that particular shed, so that constrained it. To look at the co-benefit value, we took advantage of the fact that New York City has actually developed a co-benefits calculator, and this was developed by a consulting team through a process that went on for a period of time, and essentially it puts a dollar value on the co-benefits of green infrastructure. So there's a $1 per gallon captured value over here, but there's also, pollutant removal, carbon sequestration. So we took advantage of New York City's existing work here on economically valuing co-benefits and built that into the model. So when a particular type of green infrastructure provides one of these services, we track monetarily the dollar value of that service. And then finally, the public value. We looked at the Bhutan National Happiness Index. So the country of Bhutan looks at happy people. And essentially what we did, based on the PVC values, the public value coefficients of the survey, we kept track of how happy we're making people by greening. So we know their perceptions. These were the average public value coefficients from the previous presentation for each of these types of green infrastructure. So this is the average of all four groups. So, for green roofs, 33% of the people on average will feel happy about that green roof based on their perceptions of all the different services that it can provide. So what we do at the census block scale is track at regular time intervals in the model. It's sort of like a risk type of an approach where it's dose plus times exposure. So the dose is the number. We have rules in the model that say how close you have to be to a type of green infrastructure to have gotten the dose of it, and then based on the dose of it, there's a certain PVC value that says how happy it makes you. And so what we do is keep track of the number of happy people in time. So we're tracking dollars, we're tracking happy people, we're tracking the economics of co-benefit and the amount of stormwater that's managed. And so now in a little bit more detail, I'll talk about the two scenarios. So model one, like I said, is the status quo. So based on existing New York City policies, and we're pretty much randomly placing green infrastructure in the priority watersheds. And the priority watersheds for the city are shown here on the right, and you can see much of the Bronx is a priority watershed. But our study area is sort of nested right in there. There's some subsheds that are less of a priority. So Model 2 is only a modest alternative to the existing approach. So we understand that the city is required by the consent decree to work in the priority watershed. So we're still working in the priority watersheds. However, what we're doing is placing the green infrastructure in the neighborhoods that have the fewest number of happy people. So this is simulating what would happen if New York City said, well, we're not just thinking about stormwater management, we're thinking about how can we make people happy by managing stormwater. So it's a slight change to the existing approach, but it's one that now entrains into the policy people's perceptions of the green spaces. So this is very busy. I'm not going to go through the whole thing, just to show that a lot of things happen in the model. So this is the baseline model. So we determine the capital spending for the quarter. We implement GI through various DEP partnerships. Then we implement GI on public property. Then we expand the right-of-way. Then we evaluate the program. If we're less than year 20, if we are past year 20, we stop. And we track happy people at the end. If not, we go to the next year. We find another priority spot to work, and we continue. And there's some time issues. We know that it takes a while for green infrastructure to happen, so it's not like you snap and the green infrastructure appears. It takes a year. You have to go through these different quarters. The only difference between this baseline model and the new model is that whereas here we're only the city is only tracking happy people at the end, so they do all this stuff and say how happy did we make anyone. In the next one here, we're actually at various milestones in the program, year 0, 5, 10, and 15, we determine the number of happy people in all of the census blocks, and then that goes into determining the spending. So incrementally, we're now adjusting the program to affect the happy people. So let's show the results. The first thing that was interesting to us is that neither scenario are we able to actually get to the target. So the target acreage in Bronx River watershed is 778 acres. Not Bronx River watershed, sorry, in our study area, which includes Bronx River and these other watersheds. And the box plots here show for the baseline model on the left and the co-benefit model on the right, and the number of, I think we had 750 simulations. There's a statistical approach for determining how many times you have to run the model to represent all of the sort of various permutations of the random for the stochastic features. The box plot represents the rest. So you can see the red line corresponds to that 778. So the middle interquartile range, neither one of the models actually gets there. There's a couple more on the right. Model 2 is a 10% improvement over Model 1. And we think that the reason for that is that in the distributed approach, so in the co-benefit model, looking at happiness is encouraging the city to space out or to spatially differentiate. They're not greening this block and then moving to that block and greening that block. They're sort of working, they're sort of distributing their investments around the neighborhood. And so you get more bang for the buck from the green infrastructure that you're building. And over time, over 20 years, it generally leads to a greater number of greened acres. But the real constraint here, the reason that we're not reaching the 778 is economics. It's the money that's available is not enough to get there. So so here you can see that broken down by sub-watershed. So Bronx River, Hutchinson River, blah, blah, blah. And you can see over there in Model 1, it really maxed out. The top priority in this was the Bronx River watershed. It's an impaired river. So you got close to the target, 233 in the Bronx River, but you fell short of the target in the other watersheds. Where in Model 2, by focusing on happy people or trying to make more people happy throughout the Bronx, you kind of distributed your investments in the different watersheds. There's a different, one sort of spatial implication of this is that you're distributing the investments in different watersheds simultaneously. Here's the economic value of the co-benefits. As you would expect, by trying to make more people happy, you get more of these co-benefits. So Model 1, 18.7 million in co-benefits. Model 2, 19.9 million. So, in selecting green infrastructure that makes people more happy, you're you're moving into co-benefits that are economically more valuable, at least according to the city's calculator. The numbers down below show you at the end of the 20-year program, what's the sort of running value of the recurring services. So Model 2, you're getting $2 million a year of services from the investment you've made, and cumulatively you've done almost 20 million. So about $1 million difference. You can see that in a temporal graph on the left. There's also a difference in which types of green infrastructure are built. So this is bioswales, community gardens, permeable pavement, permeable playgrounds, rain gardens, green roofs, and tree pits. In pretty much both models, bioswales are going to be a major feature. So that was interesting. And that's based on spatial opportunities. You just have more opportunities to build bioswales than you do parks, community gardens, etc. So you see in the co-benefit model, you actually get more bioswales than in the baseline model. There are community gardens have the lowest cost-benefit ratio, which was interesting because if you remember from the previous study, we were finding that community gardens, especially the cultural services of community gardens, are among the highest. But you simply don't have enough community gardens in the Bronx to actually bring that to fruition, right? So, one thing you might say is, well, there are opportunities for building more community gardens because people tend to like them, and you can make people happier that way. They do have a very low cost-benefit ratio, so you get a lot of value from them. They're just not that many. Another point that came out of this, which I think is really key, is a lot of people talk about the return on investment of this, and they say the co-benefits are what's going to make green infrastructure make sense. And if you calculate a return on investment based on the co-benefits that we got here, you get 150 years. So we don't think that you want to justify green infrastructure based on the return on investment on the co-benefits. That it makes economic sense to build green infrastructure compared to a tank or a tunnel. So that's one discussion. A tank or a tunnel to manage stormwater versus lots of little things distributed in the community. That was the original impetus for building green infrastructure in New York City, is that it appeared that you could get more stormwater management at lower cost if you distributed those investments around the neighborhood. We've now seen it's very difficult to find the sites to build those things, so it's not necessarily going to be true. But at least using New York City's green infrastructure co-benefits calculator, it does not seem that adding on top of that the co-benefits is going to get to a return period that's 5 years or 10 years. It's still going to be over 100 years. In part, that's because the annual O&M fees, so the O&M of green infrastructure is significant. And so we shouldn't sugarcoat that. So here's the number of happy people. So just for reference, if everyone in the Bronx was happy, without financial and institutional constraints, the maximum number of happy people is about 165,000 that we could have achieved here. We had a difference of about 10,000 happy people between Model 1 and Model 2. So Model 2 did make 10,000 people happier. This graph here shows the difference between Model 1 and Model 2 at the end of 20 years. So we did this all at the census block level. So there were about 1,300 census blocks where at the end of Model 2 there were more happier people. An average increase of 10 happy people per census block. So think about the block where you live on. If 10 people were happier, I don't know, maybe that would have an impact on your life. But it certainly suggests that we can distribute the investments in a way that has a bigger, we can maximize the public value of green infrastructure if we think strategically about how, even within the most sensitive watersheds, we implement our investments. So conclusions here, at least in this watershed, and the level of funding that has been invested to date in green infrastructure, it looks likely that there won't be enough money to get to the goal, the stormwater capture goal. And I think this is nothing new. cities like Philadelphia and New York know that going further and further in their program, there's going to need to be more private property activities and more cost sharing, more partnerships. So that's not necessarily new, but it sort of emerges clearly from this modeling activity. The city will likely need to encourage private property GI, and there's a lot of other people who said this. In New York City, there was a report done at NYU, collaborating with NRDC and others. But then to get to, and this was the question that was made earlier, so public approval of GI may be a way of fostering that private investment that's needed. And so that's where this approach potentially of thinking about the stakeholder expectations could come in handy. So the monetary value of the co-benefits is insufficient to cover the upfront or ongoing costs associated with GI. So we don't think that co-benefits should be used to justify the cost of GI. It should just be looked at as extra value. If you do this and the cost justification compared to a tank or a tunnel is in your favor, then you get this stuff for free. This is extra value you get. But it's not necessarily going to pay back it's not going to pay back the initial investment. Both models result in more than 125,000 happy people. These are underestimates. We used, certain figures of like how, you may take a bus to work and on your way to work pass a rain garden and think it's pretty. We didn't take that into consideration. We only looked at the stuff that you see on your block, and then we used for the parks, number's not coming to me right away, but there's some work that's been done on how far people will travel to a park. So we use those distances. But in general, we're conservative in terms of the exposure. So these are conservative numbers. I do want to point out that we did not consider unhappy people. So there are some people who are unhappy about green infrastructure. They don't want to have to rake the leaves. They don't like to sacrifice part of their park for a rain garden. They want to have barbecue pits. We didn't consider that. So, technically, if we were to continue this work, we might want to look at that. But we'd have to do more surveying to find out what people don't like about green infrastructure. So Model 2 successfully produced more happy people without sacrificing stormwater management. In fact, we captured more stormwater. But the results suggest that New York City could achieve more synergistic results by thinking simultaneously about stormwater management and public values. And that's where we think it would be interesting to see green infrastructure go at a national level, as we sort of get out of this initial pilot phase. We are out of this pilot phase of green infrastructure. If this program is to continue, that seems to be what's necessary. So that's the second presentation. Happy to take questions on this.
There's an online question.
Yeah.
So people are asking, can you speak on the so-called co-benefit of property values over longer term horizontal, so that where green infrastructure invention may lead to residents displacement? So that like in the longer term, a different population example might be benefit from green infrastructure.
Well, so this is certainly something that so the question, as I understand it, is about gentrification, right? Green gentrification. So if you green neighborhoods and make people more happy because you've improved their park, do you actually also simultaneously move them out of the neighborhood, because then the property values go up and they can't afford to live there, and then people move in who have more economic means? That is, certainly something to consider, and not something that we were able to build into this model, because we did try to do that in a previous model, agent-based model that we looked at in Philadelphia, but it's really difficult to predict the impact of, sort of demographic impact of in cities over time, because it's influenced by a whole bunch of factors that are above and beyond what could happen with green infrastructure. But I certainly do think that that's something, especially in a place like the Bronx, where a lot of the residents live in renter-occupied units, as opposed to, in places of Philadelphia where they're homeowner occupied units. There is that chance. I I don't know that the research is out there. There is certainly research out there that suggests that, and we've had in this very seminar series, some people talk about green gentrification and, you know, things like Brooklyn Bridge Park or Central Park, or these large green spaces and the impact on displacement, and that is real. Whether the scale of what we're talking about here, small rain gardens and pocket parks, could lead to gentrification, I think is an open question.
Actually, I have two. The economic value model that you mentioned, is that usable in other cities, or is that available?
Well, it's DEP's calculator. So it was developed specifically for New York City. Whether those values are going to be relevant in another city, I don't know. But since we worked in New York City, we used it. But you can certainly access it on the DEP website.
Second thing is, looking at the pervious playgrounds,
Yep.
it seems like they get short shift because they may not have the number of ecological services, but if you look at public health and other human benefits, it seems like it could rate higher.
So, like, in other words, if you were to say that because you built a playground, kids are running around and, you could have obesity benefits, for example. Yeah. So,
Better life.
yeah, exactly. Yeah. And, this whole idea of which co-benefits to value and how to value them is kind of a really complex thing. And so we chose not to tackle it, but to focus on, the city had developed its calculator and its list of, so we kept track of just those. But I can say, in New York City, the permeable playgrounds, many of them are happening in existing playgrounds that are getting, just getting a facelift. And, it used to be, an asphalt space, and now it's a permeable space. And so the kids may have been running around previously. They may have skinned their knee more frequently. But I don't know that it's resulting in a net increase in playgrounds, although it might be. I just don't know. Any other online questions? Okay.
I had a question on the
Yeah.
financial. If it requires more private investment, homeowners, et cetera, there's a lot of challenges in the lower Bronx in terms of, private investment.
Yeah.
So, in terms of fighting that gap, where in the future.
Well, so in other words, so you're saying in a place like the Bronx where potentially property owners don't have a lot of resources at their disposal, how would such a program be structured, right? So we had done previous research in Brooklyn. This is in a paper we published in 2007, so it's a little dated now, but to look at a policy whereby a private property owner has to make a home improvement. Let's say the roof is leaking, and they're willing to fix their roof in a conventional way, and they'll put that money up, but they won't pay for a green roof. They're not going to pay for the amenity on top of that. And in the study that we had done in Brooklyn, it seemed like when you compare that marginal cost, so the private property owner does a conventional thing, like they have to repave their backyard. And I realize that's not necessarily what you're talking. You're saying, well, hey, there may be some people who have no ability to do anything. And in those cases, I don't know, it's not going to be cost effective for the city to replace everyone's roof and pay for the whole project. Because at that point, when it comes to stormwater management, they're going to say, the cost of doing all that, we might as well just go build a big tunnel in the ground, right? So there has to be some cost sharing. And if and there's different ways you could slice that, but if you slice it, at least at this previous study, at the difference between the conventional surface and the green surface. So I need to replace my sidewalk because somebody tripped, and I'm going to get sued if I don't do it. I'm going to pay for a standard sidewalk. But then the city comes in and says, I'll make that permeable for you. and they pay the marginal difference, then it's a potential win-win because it's cost effective for the city compared to their alternative, and you get a green option without having to pay for it. So, that's an interesting. I think there's a lot of room for sort of discussing that. Like, how could one of these companies, these property management companies that manage lots and lots of properties in the Bronx, I'm assuming that they do certain, although it may not be true, but there's certain maintenance activities that they have to do, otherwise the inspectors would come and they'd be, kicked out of everything. So how can you structure an incentive there to, you do what you're doing, but we're going to help you do it better, so that it's good for you and good for me. Like that to me would be an interesting place to discuss. And I'm not sure that there's much. I know that there's some work happening on that. I think NRDC is doing some work on that.
I mean, does that homeowner have to get a permit before he can do the work on his roof?
Well, these become some of the potential carrots, right? Like,
Yeah.
can you make my roof happen faster? Can you provide a contractor so I don't even have to go find, who's going to do my roof? Here's the standard list of contractors. Like that's. Can you buy into a co-op that maintains this property so you don't even have to worry about it? You're going to pay a maintenance fee, and that's going to. I mean, there's ways that you could potentially
The city could
incentivize.
simply advertise, look, if you're going to put a new roof on your house, come to us, we'll pay the difference if you put a green roof on.
Yeah, and potentially this could have economies of scale on the contractor side. Like if I'm a permeable playground installer, and I know that I could get on the city's approved list, and that means that you're going to guarantee me 20 playgrounds next year. Well, my cost per playground might be less. So there's a lot of interesting win-wins that could come out of being creative here. Okay. So with that, thank you for coming, and we'll see you next month. Do you remember the topic for next month? No. All right. We'll tell you what the topic is next month. See you then. Thanks.